Okay. Okay, so this is the website. Okay, so first thing you want to do is open up your first lab, which is the first lab would be something like this one here. So if you open up that, okay, and then you have to follow those instructions that's on there. So okay, enable editing. All right. So when you come in here, and then this one that will tell you exactly the name of your project would be the name right here. So that's what we're going to call our name of a project is come in here, go into in Visual Studio, click on new project, and let me see, it's going to come in, and then look at this side, make sure it's Visual C++, come up here, make sure it's Windows 32 console application. And then you come in here, type in DLab, so DLab 01, fall 2020 underscore logic gate. Okay, and then you want to do browse where you want to save this one. I'm going to put it in my desktop because it's easier for me. And I'm going to put in this temp folder. You can put anywhere on your C drive or your D drive, whatever drive you have. Okay, so I'm going to go in here. And I'm going to put in here, I'm going to put it there. Okay, I'm going to select that folder. That's where I'm going to put all my program and where it's going to be at. Okay, so now I have that there. Click OK to go to the next one. And then it comes in here and say, welcome to, and then you want to click on next. And then come in here, uncheck these two, click on empty project and click on finish. And so, okay, so now we just have to wait until it's finished loading. Now setting up a template.
Mr. Sam, any possible? Can you make a little bit bigger?
Bigger as in bigger. Okay, so all right. So let me see if I can go in here, maximize that. Okay. That's the best I can do for now. Okay, so now I have to do is goes in here, right click on that, go down to properties, and then come in here and choose this say no common language. Click on this arrow pointing down. Choose the second option, say common language runtime support /CLR. Okay, click on that, click OK. All right, next thing you want to do is go into your project again, which is the one with say C++ here. Right click on that, go to add, and you click on this one, and then this one, the source code for this one. So this one is going to be DLab 01. So DLab 01 fall 2020 logic gate .cpp. Okay, so we want to put that extension for C++. Click on add, and now your template is ready to go. Okay, so now I have to go minimize this one out the way. I need to go back into the website one more time. So go into the website. Okay, so I want to go in here, go into the handout. I'm going to grab the first sample program. So this is your digital, and here's the sample program. Click on that one so I can use as my sample. So come in here, Control A to highlight this whole thing, Control C to copy. And so I minimize this out the way. I come back in here, and then I Control paste here. And then I want to do is go through and change it according to the name of my project. So this is DLab 1 logic gate. So I want to change everything here. Fall underscore logic gate. Okay, so that is going to be the name of my program. So I'm going to copy that one and then just goes in here and paste here. That's one, and then it come down here, it says test program, and we change that to Control paste here. So that's represent my test program. And then there's something down here, it says C out line 28. So I have to change that to, for this program, Control paste. Okay, so now I have all the places where I need that, the name of that program. Okay, next thing I want to do is come in here, look at the programmer. So the programmer would be me. I'm going to put my name in here. And then I'm going to scroll down here and put wherever my name is. I want to go ahead and do that. Just focus on one thing at a time. So Okay, so now I got all my names. So next thing you want to do, version date. So this is, today is November 17, November 17, 2020. Okay, so I have that type in. So I just do is control copy that one and then just come down here wherever the date is. I change it according to the date, this date. Okay, so control paste and that's it. And that's the only place where that date should be. Okay, so I'm going to tidy this one up a little bit so it's easier to see. Okay, so now we have that. Now what I want to do is just come in here and just clean up this one. Okay, so now look at test one is starting here. So now I have to do is just get rid of all the other tests. I just need that one test. Okay, I just get rid of all the tests. I need the this ending must stay here. Okay, so now I have just the one test to look at. Okay, now go back and when you did do this, you get all these information and you transfer it over to fill out this one. Let me go ahead and open up the one that is from the my folder so that way you can see. Okay, so come in here and go in here, this test fall Excel, and then this one is the DLab number one. So DLab number one here, open it up. Okay, so now I have my Excel. Let me see Excel hidden behind. Yeah, I have to do this. I have to do my split screen in order to do that. To do all that. Sorry if
Yeah, it's okay.
is my screen too small at the.
I'm good. I'm good. Thank you.
Okay, okay. So therefore now I have to do just go. Let me see. I scroll this one here. So I'm going to go in here and sort of going to my view screen. Let me see. Freeze my pane. Now I have that freeze pane. Now I can scroll over. Now I know exactly match it up with the test and the number. Okay. So this one, my first one. So the first one is going to be, okay, so test number. So test number would be my first one. So this is test number one. So test number one here, make sure it match. So this is the test title. So therefore I need to copy that one. So copy and then come in here, say test title. I just highlight that, control paste it. Okay. So now I have to do is what my expected data. So this is, this I'm going to put it my info from port C. That is for my information. So you want to put anything that you, so remind you where that thing's coming from. Okay, the expected data would be test one here. So this is going to be 0, 1. So this is data from port C. Okay, and then my mass data, it will be here. It's also from this data. Okay, so data from port C. Okay, so now I know where that information coming from. So this is also uh, data or info, yeah, data from port C. So this is just for myself. Okay, so this is my input. Input is would be here. Input in this case we're using only port A. Okay, so port A, which is right up here. So therefore, this one right to port D. So therefore, I change it to port A because that's what my input is from A. And from A, test one would be right here. So test one, if I scroll over to the side and test one, it's going to be 0x00. So this is 0x00 is correct. So this is data from port A. Okay, so now I have, okay, so that is completed right there. So now I have to do is just go up here and build it to make sure that there's no error before I start copy and paste. Okay. Okay, so it said one right here. It says succeeded. Okay, so therefore now I can go and copy this first test. Copy, go into a couple of lines below, paste. Okay, now I change it to the next test. So test number 2 and test 2. So that's look like test 2. It's so therefore I change this title to 2. And what is my expected data? The expected data is still 0, 1. That's good. That's okay. And the mass data, you only have to do is state the mass data one time. It doesn't change at all. So in this case, I don't really need this to repeat this one here. And this peak off, it doesn't change. It goes through all the tests. So therefore, I don't really need to do it again. I just have to do it one time in the test number one. Okay, so this one, I don't need to add. I don't need that one anymore. Okay, so now I have to do is just do test two. Okay, so test two here and match up with your input from test two. So input right here, test two is 0, 1. So come in here, put 0, 1, 0x 0, 1. Okay, and that's it. And so keep on doing that repeatedly to the next one. And so now we have to do is just copy that and then paste it, and then change it to the next one. So 3 and 3, and then you look at your input. Okay, output is 0, 1, and your input is 0, 2. So right up here, so this one has to be 2. Okay, and so on and so on. So now we have that, and then we have to do just break that, control paste. Now we have to do this one with test 4, and so this is going to be test 4, and my output, my expected on 4 is going to be 0, 0. So therefore I come in here, put 0, 0, and then write to port A. So test 4 would be here, 0x03. So 0x0. So this has to be 3. Okay, and so on until you get do all 16 tests. Okay, so once you got all 16 tests, and you make sure you make sure you build it, rebuild it to make sure that there's no error. Okay. All right. So once it's done and it has no error, and then you want to do is go to your sheet here, like I have mine right here. Now I already have this my program already. Let me go ahead and Control A. So let me say delete that one. So I come in here and look at my look like this program is working. I could Control A here to highlight the whole thing, Control C to copy it, and then I can come into my Excel and Control paste and put it here. And then now that I have all this information, now I'm ready to upload this to, and then I make sure I save this and before I upload it to the website. Okay. And then when later on, when I need to run the test, I just come in here and look at the program here. I copy this one, put on the Visual Studio, and run the test with the board, which is the board that I built right here for DLab 1, which is the top row here, with this control box here to test your software to make sure it's working or not. Okay, so if it works, and it should be able to pass all the way through the test. If it's not working, then then we'll have to spend some time together, or I will send in the information.
Okay,
And
thank you for your help. But my question is only please go up to the top of the program here. The top of the program is the line number 2. We need to type exactly so in the solution explorer name of the source file. Sometimes I type the file name is a different of the source file in the solution explorer.
it doesn't matter what you put in your solution. You can put the source file differently.
Source file is different.
It does not matter. It's just I can say I can copy this whole thing and say I can copy it. So it's say I can copy this one here, and then I delete this whole thing. I can go up to so I delete this one whole thing, and then I can go in here and say I don't need that, so I delete that. Let me see. I can come here and say remove it, and so remove it. Yes, I want to remove that whole thing. Now I don't have source. Now I can go back in here and create the new source. So therefore now I create new source. Come in here and just put logic gate .cpp, and so therefore now I click on save, or I can say DLab, or I can say DLab 01, and I know that it's referring to 1, so .cpp. Okay, so anything like that, I would know that referring to first lab. Now I just Control paste from what I copy from the other one. Now I just come in here, make sure that I have in place. Okay, now this one is for this lab. Now I can do the same thing. I can build it, make sure that this is compiling into this folder. Okay. So now I only have this source file. The other one I already removed out. Okay.
It doesn't matter. Is a different or
Doesn't matter this one, as long as you name it something that we can refer to, that we can identify quickly. If you just refer to DLab1, if you put DLab1, it's easier for me to know when you upload this, it's referring to DLab1, and so it's easier to me to identify. Okay, but if you put logic gate, then there's a couple other one that also has that logic circuit, logic gate, logic circuit, and I think there's another one that said logic gate. So therefore, it's maybe causing a little bit of confusion. But if you said DLab1, then it's me, DLab1. Okay.
Okay, thank you very much.
All right.
Thank you, everybody. Yeah.
Okay. Thank you. Okay. All right.
Sam,
Yes.
well, on that, it didn't really matter because the green's just notes. It depends on save as.
Yeah,
Right.
but you want to create a good habit of creating something that, you know, that you have some information.
No, I understand where you're going.
Always, yeah, always create. I know that an extra step, but you want to create a habit of doing that, because if you're going to be away from this one and later on you don't know, you have to go back and do it. And now you said, okay, where did I get these information from? Where do I get, you know, how do I how do I get where is this one coming from?
Yeah, consistency versus your notes. No, I understand.
Yes. So the more notes you make for yourself, it's going to be making easier for you. I said later on, say that if you transition over to work with a company, and then when you're working on their software and you put a note for yourself, so that way you know exactly what is going on at that particular point, and say that you need to test the circuit. Okay, I need to test that circuit. Now I have that information that I can refer to where it's coming from. Okay. So always make that good habit, and yeah, like I said, extra step, but it's going to be, yeah, it's going to help you in the long term. Okay. All right. Okay. Anybody ever have any other question?
Okay, Sam.
Okay. Back to Mr. Pham. Thank you.
Okay, make sure you guys download number 3. Take one sample test. That's what we go through right now. Okay, download that. Take one sample test. Okay, so number 1, you know that will be Jfet will be a voltage controller device. Okay, that will be A. Number B, the input impedance Jfet will be approach infinity. That will be C. And number 3, the weight of the gate will be controlled. A or B or C or D. The answer will be D. All of the above. That means they control the weight of the channel, the drain current, and the gate voltage. Okay, the gate source diode of the Jfet should be reverse bias. That will be B. Compared to a bipolar junction transistor, Jfet have much higher than input resistance. Number 6. The pin-off voltage at the same magnitude as the gate source cut-off voltage VCS off. D. Okay. 7. If the critical frequency of a low-pass filter increase, the bandwidth will be increased. Number 8. If the critical frequency of a high-pass filter increase, then the bandpass must be decreased. Number 9. If the Q of the bandpass filter increase, then the bandwidth will be decreased. We want a narrow band. Number 10. The term pole in the filter terminology refer to a single RC circuit. Okay? That means you get 2 poles, 2 RC, 3 poles, 3 RC, and so on. 11. A single resistor and a single capacitor can be connected to form a filter with a roll-off of 20 minus 20 dB or minus 6 dB per decade per octal. That will be D. Number 12.
Fam, how we got this negative 20 dB and negative 40 dB and negative 6?
They equivalent.
But what's the calculation? How to do it?
Let's see. Octal mean 8, right? 20 dB mean decade mean 10. Okay?
Mm-hmm.
That will be, if, let's say, basically, roll-off rate will be 20 dB. So you have to converting 6 dB per octave to get the same minus 20 dB per decade. Or you can change minus 20 dB per decade to go to the minus 6 dB per octave. Okay,
Okay.
I'm not paying much attention on that. So not ready for you. But
Okay.
they're the same, equivalent. Number
Okay.
12, a bandpass response head. They get a true critical frequency, upper and the lower. Okay, so that will be A. 11, the lowest frequency passed by a low pass filter will be 0 Hz. Answer will be B. 14, the quality factor Q of the bandpass filter depends on. You know the formula to calculate Q, FC over the bandwidth. So 14 will be C. 15, the number of poles, the filter F5. That means you get 1 pole or 2 poles or 3 poles. So the roll-off rate will be changing. So the answer 15 will be D. 16. When filter cascade run-up rate have to be increased. A. 17. When the gain of the filter is minimal at its center frequency, so it will be, the answer will be D. The thing is that will be band stop filter, or they get another name here, not filter. Okay, so the first output will be a band pass filter C. The second, that is the output of the low pass filter. Okay, and number 20, the output that will be a band stop filter or notch filter. Okay, and 21, okay, that will be output of the high pass filter. Jfet always operate with get to short PN junction must be reverse bias. A. 23. For Vz equals 0, the drain current becomes constant. When VDS exceeds V ping off VP, answer will be C. 24. The constant current area of a Jfet line between ping off and breakdown. Last one. At cutoff, Jfet channel will be completely closed by the depletion region. Okay, so this is you guys don't have to do anything. But next test, you have to get the file for the receipt, recorded. After the test, you must be uploaded right away. Okay, so any question about the test?
Do we have random study sources?
What do you mean random study source?
Is there a particular file to reference or just random information from past weeks?
Everything. That means whatever we already talking to you guys in this fall semester will be covered. That prepare for anyone need interview for the job, then you will be ready. I'm not asking much or more detail in the calculation. If we do the calculation, I will be giving you the formula. You don't have to memorize the formula. Only thing you know how to use the formula.
Okay, the student has a question. When will that test?
Not yet. However, next week will be no class. Okay, that's holiday. And after next week, we get almost around 6 weeks to the end. That means 3 weeks on the December and another 3 weeks on the January. So at least you will be get 5 more tests. Okay, try to cover everything. To me, you need to get through it. You can do it right away. Okay, the thing is when you get an interview, you don't have any notebook, anything else. You have to answer right away. So that's what I want to helping you. Okay, when you're looking into the question, you're able to answer right away. That means you're okay.
Hey, Mr. Pham, you're going to have a class on Thursday this week, correct?
Thursday, you guys still get the the class with Mr. Thai. Tomorrow, take you will be get a class with me. Okay, is it the time for the test is too short or too long?
Perfect.
That's okay, right?
No, it's too short time.
Okay, so basically one question I given you 1 minute.
No, it's not like that. The first 3 questions you give only 2 minutes.
Okay, next time, if you get 3 questions, you get 3 minutes.
Thank you.
Thank you.
And
If there's 4 minutes, that means we can use the internet, right?
anything with the calculation, the time may be given a little more.
What's wrong if you use your notes or internet? That's the same.
You have to type quick.
Okay. So the thing is, no matter what, we try to help your guy. Okay. After this semester, you really understand in basic electronics. Okay. In more detail. This is the first time, first semester. I believe I did very good. Okay. Okay, so now we go into the Jfet and the Mosfet. Okay, that's what we're doing now. Okay, I say if you not quite understand, then you could go asking me. Okay, I try to make it clear for you guys. Thing that you made, even the time I work in the university, I still not really understand. Okay, so that's why I try to find too many different ways in order to helping you. Okay. Now, the first time you understand on Jfet, you get the two type of amplifier: common source, common drain, and common gate. Okay. And I get a question for the sample test one. Do we need to turn in? No, you don't have to do anything. I already given to you answer. Okay.
Yeah, this is for you to study for the final, for the exam. Okay, so this is will give you more more testing, sample testing, and you have to use this to study.
That 2, that 3, not sample anymore. Okay. So the first one, common source. I just like to asking you. Okay, when you're looking into the circuitry, you're able to recognize that will be a common source amplifier. Input applied to the gate, output will be from the drain. Input output will be 180 degrees out of phase. Okay, basically, in the field job, they not try to asking more detail like calculate the gain or whatever. Okay, they just in general. So this is just a calculation. Okay, and let's see. If you want to know more things here, that means when you go to the college or university, then they will be go into this more detail like we do last time. But for this program, we don't expect you, okay, to understand when you converting into the AC circuitry. Only the minimum thing sometimes input impedance, output impedance, and about the gate. Same thing. If you're working on the left board, they asking you, they already given you the formula. Okay. and make sure can, common source, they will be have a 180-degree phase shift between input and output. That means signal will be opposite. Okay. Okay, the next one will be a common drain. Common drain, they get another name. That will be a source follower. Same thing in the bipolar. You get common collector, and they get another name will be emitter follower. That means emitter and the output will be the same. In that one, they call a source follower. That means the output and the source will be the same. Okay. So if you're looking into that, you can see that is the output here, and that will be the source right here. When you converting to the AC capacitor sorted, so the voltage at the source or voltage at the Vout will be the same. That's why they get the source follower. Okay, for the common drain, input applied into the gate and output will be from the source. Okay, and the signal will be in phase. Okay, and you understand Jfet amplifier get less voltage gain. Okay, and last one that will be common gate. Okay, and the common gate, that means the gate will be routed, and that's the AC circuitry. Okay, now this is the circuit. You can see the gate will be routed. Okay, right here. Input will be applied to the source. That will be a source. Okay, and the output from the drain. Okay, and input, output will be in phase. Okay.
FM, what's the use of common gate amplifier?
Common gate means gate will be routed for AC.
No, but what's the use of that one? Why we are using common gate?
Depend, they say common gate and has a moderate voltage gate. Okay. It's a big drawback is that G in is quite low. The circuit will low, so C common gate amplifier. So basically depend on the application. If they want to let, input impedance, that means they will be using the common gate.
Okay, thank you.
Yeah,
And the drain and the RL, they're in parallel, right?
RL, RD will be in parallel for
Right.
output impedance.
Okay.
Okay, now we go to another one. Metal oxide semiconductor Mosfet. So now you see that's a symbol for N-channel Mosfet. Okay, and this will be a P-channel Mosfet. One the arrow coming in, another arrow coming out. At least you both know. The thing is that what normally they asking. They can give you the symbol, that one, and they can ask what they did. So you have to say that will be a MOSFET N channel or P channel. Okay. The MOSFET can be operated at two modes: depletion mode and enhancement mode. Okay. Sometimes we call it depletion and enhancement MOSFET. Either positive or negative gate voltage can be applied. That means that's a different from Jfet. Okay, they can apply positive or negative gate voltage on the depletion mode when the negative gate to the source voltage applied, and enhancement mode when positive voltage applied. So basically, they can using either power supply. However, they get two different mode, depletion mode and enhancement mode. So based on the gate to the source apply, if they negative, that means depletion mode. If they positive, they will be enhancement mode.
And Mr. Pham, I don't want to get too far in front of you, but it says metal oxide semiconductor FET MOSFET, and then it says D MOSFET. How many different types of MOSFET? Is there a D, a E, a F, or what?
Now they get a D.
Just D?
Yeah,
Okay.
they get a two different mode. E MOSFET or D MOSFET.
What does D stands for? What does D stands for here?
Depletion.
Oh, so if it is enhancement mode, it's going to be E MOSFET?
Yeah.
Okay.
Like D or E.
Okay.
E means enhancement.
Mr. Pham, is either the N channel or P channel more common than the other?
They're the same thing, they did the opposite,
They're both used pretty equally though?
Yeah.
Okay.
but they opposite. Okay. Normally, the book talking about N channel only. Now, E MOSFET, you see that? That means enhancement. So again, they can get D MOSFET or E MOSFET. How do we know they will be a D? How do,
Negative gate to source?
how do we recognize this is a D MOSFET?
Because up top, it said something about one was positive something and one was negative something.
Exactly. Depend on the gate to source voltage applied. If a negative D, if a positive E. Okay. So E MOSFET, okay. N channel require positive gate to the source, right? P channel require negative, they just opposite. Equation transfer characteristical differ from that of the Jfet and the D MOSFET. The MOSFET will be working almost the Jfet. However, E MOSFET is not. Okay. So up to this point, Jfet, MOSFET, they can be operate either the MOSFET or E MOSFET. Okay. Depend on the voltage applied to the gate. If the negative, that will be D MOSFET. If a positive, they will be E MOSFET. Okay, D MOSFET will be working almost the same like the Jfet. However, E MOSFET is not. Okay. Now, if you're looking for,
I have one question. Then why we are using D MOSFET?
no, I don't know. Who cares? Okay.
Okay.
If you're designer, then you need to know when we need to using this guy or the other. But we are the testing. We need to know how they work it in order to fix it. Okay?
Okay, thank you.
Yeah, no problem. You go after this school, you go to the college. Okay?
Okay.
Then you can get it. So now you can see, okay, the Mosfet transfer characteristic. Okay, so the Mosfet, you see the conductance, same thing like Jfet. You get a VGS up here, and you get the IDSS. Okay, that for N channel and that for P channel, same thing like Jfet. Okay, and we already know Jfet. Okay, now for a certain the MOSFET IDS equal 10 milliamp and VGS up equal minus 8 volt. Is it an N channel or P channel? Answer me that question first.
N channel.
Example.
N channel, because you got -8 volts on VGS off, so it's got to be N channel.
N channel. Okay. They want to calculate the ID at VGS minus 3 volt. Can you do the calculation? You know the formula? ID equal IDSS times 1 minus VGS over VGS off square. That's the minimum thing. You have to do your own calculation for me. Who get the answer, let me know.
6.25 milliamps.
Okay, you get 6.25 milliamp. I don't think so.
Okay.
I got that too.
Is it you get a IDSS mean 10 times 1 minus to minus 3 over minus 8 square.
Oh, I didn't square. That's why. $1.4 milliamps.
How come I didn't see it same?
3.9.
I got 3.91.
What you get?
3.9.
Exactly, 3.91 milliamp. And then number C, that will be calculated for VGS equal plus 3 volt. Who get the answer?
$18.91 milliamp.
Can you say again?
18.9.
Okay, you're good. That's what I gave it to you. Okay,
Wait a minute, hold on.
Mr. Pham,
yeah,
so for C, VGS is positive 3, am I right?
positive 3 volt.
So it's going to be 1 plus 3 over 8.
Minus plus 3 divide minus 8. So you get that 1 minus mean plus.
And how it's multiplied by 2 is multiplied by 2 or square it is?
What do you mean multiply by 2?
It should
You-
be square. It should be square.
Okay, thank you.
Yeah, that's it. I'm lazy, so I not bring it up. On this example, I don't do it. You guys get the time. You can do related exercise. I just talking about general. The Mosfet IDSS 18 milliamp. VGS off equal plus 10 volt. Is it N channel or P channel?
Where?
Channel.
The answer will be P channel, right? Then the next one, you have to do calculation the same thing, okay?
Wait a minute, go back, Mr. Pham, for just a second, right there, hold on. Okay, thank you.
Yeah, you're welcome. Now, E Mosfet. You can see E Mosfet, the train conductance different. You don't see any VGS off, but they get a VGS TA, okay? Threshold for N channel and the P channel. So basically, if you're looking into this train conductance display, and you know that will be for E Mosfet enhancement, not D, okay? Now, try to see what they say right here. Okay, E Mosfet, okay? N channel divide require positive VGS and the P channel require a negative VGS. There is no drain current when VGS equals 0. Therefore, a MOSFET does not have IDSS. Okay, each channel don't have a IDSS. Notice also that there is ideally no drain current until VGS reaches a certain non-zero value we call a threshold voltage VGS. The equation for the E MOSFET transfer characteristic EID equal K times VGS minus VGS squared. On the D or Jfet, ID equal IDSS times, okay, 1 minus VGS over VGS of square. However, E MOSFET equation quite different, okay? The constant K depend on particular of the MOSFET can be determined from data sheet by taking the specified value of ID. They call a ID on at the given value of VGS. Okay, the data sheet of Mosfet, they gave an ID on equal 500 milliamp, SVGS equal 10 volt, and VGS equal 1 volt. They want to know the drain current for VGS equal 5 volt. So the formula, first thing you need to calculate the K. K will be equal ID on divide VGS minus VGS GS square. That given to you 6.17 milliampere per volt square. Then you can calculate ID equal K times VGS minus VGS GS square. Okay, you get 98.7 milliamp. Okay. Handling precaution. That's what we already telling you. Okay. Most device subject to damage from electrostatic discharge ESD. Most device should be shipped and stored in conductive form. All instrument and metal band, assembly or tape should be connected to the earth. Ground. The assembler or handler wrist should be connected to the earth ground with the length of wire and a high value of series resistor. Never remove and most device from the circuit while power is on. Do not apply signal while the DC power is on. Okay? And now they're talking about Mosfet biasing. Okay, you can see you can get the bias. Okay, the Mosfet, they get VDD 18 volt, RD 620, RG 10 mega ohm. Okay, so they say the circuit Mosfet with a zero bias. So the Mosfet data sheet given VGS off minus 8 volt, IDSS 12 milliamp, and they want to know VDS. Okay, so VGS equal 0 and ID equal IDSS. Okay, so you're using VDS equal VDD minus IDSS times RD. Okay, so that means in this case, ID will be equal IDSS. You don't have to calculate ID. That Mosfet biasing. Example. Okay. Determine VGS and VDS for the E Mosfet in the circuit shown, assuming this particular Mosfet has a minimum value of ID on 200 milliamp, VGS equal 4 volt, and VGS TH equal 2 volt. Okay, first thing, let's see. I'm looking for the circuitry. Okay, that's not this circuitry. Let's see, this is a circuit. Okay, first thing, you need to do your calculation for me. We get by voltage divider. Go ahead and tell me what you get. You take 24 volt times 15K, divide 15K plus 100K. And what I get is 3.13 volt. Make sure you get the same.
Yeah, I agree with that.
Okay? After that, now you need to find value for the K. Formula will be K equal ID on divide to VGS minus VGS TH square. And that will be given to you 15 milliamp per V square. Okay? Then you can able to calculate the ID for VGS equal 3.313. Okay, ID equal K times VGS minus VGS TH square. You get 63.1.8 milliamp. And you can calculate the VDS equal VDD minus ID times RD. You get 11.2 volt. And I can guarantee nobody will be asking you more detail for any calculation here. The reason most of the people don't know much about Jfet, especially for the Mosfet. If they not quite understand, then they never ask. A Mosfet bias. Okay. They say determine the amount of drain current in the circuit cell. Mosfet had the VGS equal 3 volt. Okay, if you're looking into this circuitry, can you tell me what VGS equal?
8.5 volt.
How? How can you say VGS equal 8.5?
VG is 8.5 and VS would be 0 because it's grounded. So VG minus VS will stick give you 8.5 volts, right?
Yeah, the thing is VGS mean VG measure to S, right?
Yes.
Okay, and S will be rounded.
Yes, sir.
So that's why 8.5. Okay, and they doing the calculation for you. I can give you that calculation. The meter indicates VGS equal 8.5 volt. Since this is a drain feedback configuration, then VDS equal VGS equal 8.5 volt. And you can use ID equal VDD minus VDS divide RD. Let's see any more. Summary, okay? That will be really help for your guy. Summary everything. Okay? The summary get that a Jfet, okay? Get source junction must be reverse bias. VGS control ID. Value of VDS at which ID become constant is the ping off voltage. Value of VGS at which ID becomes 0 is the cut-off voltage, VGS off. IDSS is the drain current when VGS equals 0. And they given you the formula to calculate the ID and the formula calculate the drain conductance GM and GM0. Now, summarize on the Mosfet, except that it can be operated in enhancement mode. The Mosfet characteristics are the same as Jfet. The depletion mode, N channel VGS negative, P channel VGS will be positive. Enhancement mode, N channel VGS will be positive, P channel VGS will be negative. VGS control ID. Value of the VGS at which ID becomes 0 is the cutoff voltage. IDSS is the drain current when VGS equals 0. Okay, transfer will be the same. Now, summarize for E, Mosfet. There is no depletion mode and characteristic differ from the Mosfet. Enhancement mode, N channel VGS positive, P channel VGS negative. VGS control ID. Value of VGS at which ID begin is the threshold voltage, we call it VGS TX. Transfer characteristic ID equal K times VGS minus VGS TX square. K in formula can be calculated by substitute data sheet value ID on for ID and VGS at which ID on is specified for VGS. Okay, they given you different bias, cell bias, voltage divider bias, or zero bias, drain feedback bias, or whatever. We don't care much in that. Now, the MOSFET amplify. If you're looking on the circuitry, okay, for this amplifier, input applied to the gate, output from the drain, okay? Particularly MOSFET yield in amplify had an IDSS 200 milliamp and a GM of 200 millisiemens. They want to know both the DC drain voltage and the AC output voltage. If the input will be 500 millivolt IMS, okay? This is the solution. Since the amplifier is zero bias, okay, ID will be equal to IDSS. For the MOSFET, then you can calculate the VD. VDD times minus ID times RD, you get 8.4 volt. R load, you can see in this one, they get RD right here and R load right here. So the output impedance will be a parallel between RD and RL. Okay. So R load will be 33 ohm times 8.2 k ohm divide 8.2 k plus 33. However, unit must be changed. Make sure if you're using ohm, they will be ohm. Or if you want kilo ohm, then must be changed to the kilo ohm. Okay, so the calculation, you can get 32.9 K, I believe. Okay, AC voltage gain will be equal to GM times R load, and V out will be AV times VE. That's what you get, 3.29. So basically, if you get the time, then you can try to do it, okay? A MOSFET amplifier, okay? They're given a common source amplifier using a MOSFET, and they want to find something, okay? This is the a MOSFET amplifier, okay? Now let's see. That is the D MOSFET amplifier, and that will be a MOSFET. Okay. When you're looking into the circuitry, how do you recognize a D MOSFET or E MOSFET? See, the circuit look like the same, right?
The voltage in is positive or negative?
Now,
The symbol is slightly different from the E MOSFET and the D MOSFET with the broken line in the circle.
exactly. That is the key. You can see that is not broken line, right? However, this one is a broken line right here. Okay? This is a symbol for E. And this will be a symbol for D. You get that?
Yes, sir.
Yes, sir.
Yeah, that is very important to you. You don't have to do any calculation or go too much detail. Okay. However, they asking you that symbol. Okay, this symbol, they're asking you what is it? Then you have to say that will be a D mod or E mod by looking into the symbol. Okay? And the way they're doing a calculation here. Okay, VGS equal 2.23 voltage divider. Then they say for VGS equal 4 volt, then K equal 50 milliamp per V square. Then you can calculate the ID. Okay, and you can calculate the VDS. That's what we already did it. Then the load, that means output impedance. Some data book they say Z out. Some data book they using a lowercase r load. That means AC resistance. They will be equal RD parallel to R load. And if you want AC gain, you take the GM time R load. Okay, that's the same thing.
At least.
That's it.
Mr. Pham,
Yes.
how come for the value of K, even though we already did square the VGS minus VGS off, do we write it like that? Like AV squared?
Okay, let's see. I'm looking for calculate the K, right?
Yes, it was on the last page too, for sure.
Yeah, the thing is that not given you in detail. Right here. K equal ID on. Divide VGS minus VGS DS square. So they will be milliamp will be per V square.
Okay, thanks. It's just kind of confusing because we already squared it, so I didn't.
No, that's a V square. That means unit square.
Oh, okay.
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 What did the K represent other than ID on?
Now the K, that is what they said in here. What is it? I believe they already explained the UK right here.
No, go up, please.
Hanley. Here.
Where it says E MOSFET transfer characteristics, that's where the K comes in at.
Noted also there is ideally no drain current until VGF reach a certain non-zero value called threshold voltage VGF. Where is the display? That one here.
Go down to the next one.
Now that one, basically for the N channel, you get the VGA, okay? TS, that means the threshold. So until this point here, you're able to get the current ID, okay? Any point on the curve right here, you're able to get the current ID, okay? However, Before VGS, you don't have any current. That's a VGS. That's what they call a threshold. Okay. Therefore, E MOSFET, not the D. The MOSFET will be the same. Jfet. Okay. That's especially you must know that thing.
You want to know what meaning of the K, so it's on the next page.
Yeah.
Go down.
Next
Yeah,
page.
it's right there. Yeah, the K is right. No, go above. Right here, it tell you explain about K. Right here, the constant K. Yes.
VGS, GS, and basically they're using the K, just the name, constant K. So when you're looking into the data sheet for the MOSFET, you will be see what K.
Understood. Thank you. Specific to a particular manufacturer component.
Right, but they're using the same. Different company, different MOSFET, but they must be using the same type of the label.
Isn't it isn't specific to civilian or military or specialized or high end?
Now, they must be the case for either one. Only the military, you understand, is the high quality. And yet, I say in commercial or in military, working identical. Okay? However, military will be cost more money. High quality.
Right. Material use. Understood.
Yeah.
Thank you.
So make sure we have a no class next week. Okay? Then after that, every week we get a meeting, we get a test. Make sure I asking you try to do your homework, and especially for textual. Right now we get a 5 lab for D lab, and you still working on the D lab 1. What that mean? You want to stay forever here. If you're not doing anything, doing it, yeah, I welcome you stay with me.
And bring potluck.
But in order of helping me to get more, happy to teach your guide, you have to get a feedback. You have to do it. Okay? You want to be a technician. Only one way. You must know how to do what to do and your knowledge. Nothing else. Okay? So, any more? Any question?
Mr. Fan,
There was nothing?
Mr. Fan, got a question. The constant K you say is usually given on data sheets?
Yeah, sometimes.
Sometimes.
Even data sheet, otherwise you have to do your calculation.
Okay, that you do the calculation is when they give you the ID on
Right.
at what VGS is and what VTH is, right?
Yeah.
Okay, all right, thank you.
This is the formula right here, right?
Yeah.
Yes.
Okay.
What's the rest of that line say? The data sheet of what? What's the end of the line say?
At the end of the
Can you zoom out a little bit so you can see what that completely says? Where it says MOSFET, the end of the line, ID. Can you zoom out? Yeah, please.
data sheet, give an ID on, right?
I was wanting to read what the line says.
So is it you get a question about it? Yeah.
Well, you're applying an example. I just wanted to see what you had written down relative to your solution. So the more that you zoom out, the more that we can read.
But it's also on the handout. It's on the website.
It's on the handout.
Yeah.
Yeah, I'm referencing right now. Thank you.
Yeah, the thing is sometimes, using the iPad here, I try to get along, try to see how can we using that for good training. Okay, for you guys.
Mr. Pham, just a real quick question. Where it says, what do they mean when they refer to ID on? If you could just say that one more time. ID on.
That's what they said, ID on. I don't know why they call ID on. You see
Okay.
that?
Yeah,
Yeah,
it says K equal ID on.
If it sounds like, well, if it's ID, it'd be current reference to gate. It sounds like.
Like, is it the range of possible current values when VGS is greater than 0?
Okay.
There's a fluctuation of the gate value, and it'd be versus a versus.
K equal ID on divide. Okay, and normally the data sheet will be given you the ID on.
Okay, thank you.
The more
Really, this time what I see a Mr. Smith, this emitter get a really, really good. The thing is before we spend wasted much time on the D lab. So that's why we not go into very, very detailed, okay, in the electronic. For texture, the lab is a very, very important. Okay. The thing is you want to troubleshooting, you want to fix the circuitry, and you still get the problem how to do your job. You must be know how to get the Excel done and you able to transfer that into your test program. Have to be no problem. Okay.
50-50, right, Mr. Pham? 50-50.
Yeah, tomorrow. Then we can talk from now on. You don't have to draw too much timing diagram now. Just the understand how that device working. Then you know how to make it work. And you know how to fix it if they're not working. Okay? I really want to teach you guys about how to troubleshoot it.
So, Mr. Pham, if it's a problem with a circuit, you don't want us to disassemble the entire circuit and start all over?
So, make sure do the lab as much as you can. You get a problem, I say just get in Zoom with me. I try to help, okay? Right now you get lab 1, 2, 3, 4, 5, only 5. We have to get it done before we can move on. Okay?
Yes,
so,
sir.
Anyway, good, you guys get a good holiday, okay? And take care. We'll see you guys after next week.
Okay, we
Happy
see you
Thanksgiving.
tomorrow.
Thank you.
Thank you, Mr. Pham.
Tech 2, see you tomorrow.
Yeah, I
See you
will
tomorrow.
thank you tomorrow. Okay? Bye-bye.
Bye-bye.